Chapter 9, Day 3, Questions 1 and 2. You're going to have a lot of these problems because they're going to be part of a whole chapter in College Algebra 121. We are giving this to you at a very low level. When you get to the college math, they will give it to you with quadratics, cubics, with roots, all of those things. But for right now, we just want to go over the many steps that you need to do. To find f inverse of x, so this symbol here is an inverse. We're going to start off with the formula for f of x equals 7x minus 9. Step 1, you're going to change f of x into y. You'll remember from chapter 3 that f of x and y are the same thing. Hey, this is function notation, and this function notation, and then this is y equals mx plus b, slope-intercept form. Step 2, we're going to take our x's and our y's, and we are going to switch them. Now, this is going to change the entire meaning of this formula. So I actually usually put a line here, possibly a squiggly line, to know that I've actually made the change. So here we get x equals 7y minus 9. Different teachers have you switch the x's and y's at different times. But since our purpose is to find the inverse, I want you to have the inverse as soon as possible. And that's how we do it. Then we are going to solve for y. Now, two-step algebra equation, we're going to add 9 to both sides. Remember that we want to see this kind of work for our college classes. And then divide both sides by 7. Now, the college professor does want the variable on the left-hand side. He would actually probably have you swap those a little bit earlier. And I will either take it like this as a single fraction, or you can make it into two fractions. This would actually be your slope-intercept form if you wanted to graph it. And last but not least, after you have solved for y, we are going to change y into f. I already took the inverse of it, x. So this says I have already switched the x's and the y's, and this is what I came up with. You can have it written like this, or you can have it written like that, whichever one makes you feel better. But because some students are having trouble with reducing the fractions, this has actually worked out really well. It also gives it 2 and y equals mx plus b. Later on in 121, when we graph these, what's going to happen is we're going to have this crossing at -9 with a positive 7 slope. This is a bad drawing. This is going to cross at 9/7 with a 1/7 slope. And what's going to happen is they're going to be mirror images around the line y equals x. Why is that true? It's because when you switch the x's and the y's, we made the same thing only backwards. It will only go a mirror image around y equals x. It won't go around y equals negative x. So this is where we're heading to in your college class. But for right now, what we're doing is just finding the inverse. Changing f of x into y, I want to see that. Switching the x's and the y's, resolving it for y, and then changing it back. F inverse, just like f of x, should go on the left-hand side. Alrighty? Make sure that this one has the inverse, and that this one does not have the inverse. Alright, continuing on. G inverse of x. I gave you a different formula here. Same steps. G of x is equal to -12x plus 3. Just like f of x is y, g of x is also equal to y. Squiggly line. I use this to make sure that I know, have I actually switched the x's and the y's? Because some people work their way around in a big circle and come right back to the original problem. So, we want to make sure that we know, yes, I really did switch the x's and the y's. If you want to have your y on the left-hand side, now would be a wonderful time to swap the sides. And then you're solving for y, showing all this wonderful work. And see, we don't usually like having that negative in the denominator. So maybe we would have this, and negative negative would make it positive. Ah, but 3 over 12 would then reduce to 1 over 4. Hey, we might not have seen that if we didn't split those up. And then f inverse of x is equal to negative x over 12 plus 1 over 4. Now, let's say that you decided not to make it into two separate ones. You could have x minus 3 over negative 12. A lot of people do not like having the negative in the denominator. So, cool trick. You could change every sign. That would give you this. And basically what we did was we multiplied the entire numerator by negative 1 and the entire denominator by negative 1. From back in chapter 6, if you multiply the top and bottom by the same thing, it is a legal move because from chapter 1, this is the multiplicative identity. And you could get f inverse of x is equal to negative x plus 3 over 12. But we do like having this denominator be positive. And if you split it up, you actually have some reducing that you can do so that you can graph it a little bit better. Chapter 9, day 3, questions 3 and 4. You might see these notations in your college class, and you might hear students speak fondly of fog and goth. Now, one of the reasons that we say fog and goth is to make sure that you know that this is a little tiny circle. If it was a solid dot, we learned that back in chapter 3. You just multiply things together. But, just like in chapter 3, we are going to rewrite it and then plug, work, and answer. So here we go. We have fog, and the way you read fog is f of g of x. And you will write it as f of g of x. This is the rewriting. F came first, f is on the outside, g of x came second, g of x is on the inside. Question on the left-hand side. We're going to have a lot of questions on the left-hand side, so if you want to keep writing these, it does not say how many steps these are. So I remember it was like 5 steps. I'll write it 5 times. All right. So first thing we do is we rewrite it. And then the second thing we do is we plug the inside. Now, you might think, why can't I just plug the entire thing? I'll tell you that I just finished working with some students in 121. They have to do this. Not only that, on the computer, using multiple choice, they have to show all of this work. And multiple choice, drag down the reason that they are doing this. So, be careful. So here, we're just plugging the inside. So the f stays on the outside, and the g of x is negative 12x plus 3. You'll remember from back in chapter 3, if we have f of something, this gets plugged into all the x's. So this says 7x minus 9. And what we're going to do is we're going to take this g of x, which is our negative 12x plus 3, and we're going to plug in negative 12x plus 3 into 7x minus 9. 7x minus 9. This goes instead of x. Then we will distribute. 12 times 7, 14, carry the 1, 84, x plus 21 minus 9, combining like terms, descending order by degree. The x's come first. 21 minus 9 is 12. Done. So, rewrite it like that. Plug just the inside, and then we're going to plug again. And then we're going to distribute from back in chapter 1. And then we are going to combine like terms. Remember in college algebra, they're going to be giving this to you with like extra things. We're going to have cube roots, squares, things like that. Here we go. We're going to do g of f of x. So g, ooh, can't write it like that yet. We have parentheses, g of f of x. We're going to rewrite it as g of f of x. It's said the same way. All right. Question on the left-hand side. Possibly writing the question on the left-hand side all 5 times, because I've seen students who write it each time and they get so caught up on the right-hand side that they copy this incorrectly. So hey, we could possibly just write that out 5 times to begin with. Make sure the equal signs are all lined up. Now, this is not worth half credit, just writing that. Here, we're going to plug in your f of x. According to that, our f of x is 7x minus 9. And then we're going to plug this into g. G says negative 12 times x plus 3. Remember I've been having you guys plug in using parentheses and plug in using parentheses? It's because this is only going to get worse. And here, we're going to multiply. Hey, we did 12 times 7 over there, and it was negative 84x. Negative and negative is positive, and 12 times 9 is 108 plus 3. Combining like terms, descending order by degree. And that's it. So, rewrite it, plug in just the inside, plug that into the outside formula, and then distribute and combine like terms. We're just trying to introduce you to the concept of composition of functions and the fact that we can have f of g or g of f. We can also use different letters other than just f and g.